Dear students, today I'm going to discuss on effect of heat on matter. It's a very important chapter of physics book for 9-10 students or SSC student. This is the first lecture. First of all, I will show what the topics I will discuss in this lecture. Number one, concept of heat. Number two, concept of temperature. Definitely, you can learn difference between heat and temperature, specific heat capacity, and some mathematical problems with homeworks. Okay, I will discuss the creative question as well at the end of this lecture. Okay, let us discuss heat energy first. Okay, heat. Okay, in general, by heat, we think that when we touches a body, uh, when it touches a body, we feel warm or cold, right? And in general sense, normally we consider heat as a warm thing, not cold or something very ice freezy. But in physics, uh, heat is considered as energy. Energy, that energy is used for work to do work. Here it is also used for doing work. How this is possible? Yes, in machine, electrical machine, we convert the heat energy to the electrical energy, and then it electrical energy will use for doing work to rotate the mechanical part. Okay, so let us write the definition of heat. Heat is a one kind of energy, one kind of energy which gives sensation of hot and cold. That means first the important thing is that heat is energy, and the last thing is that it gives sensation of hot and cold. The unit of heat is calorie. The unit of heat is calorie or joule. Uh, Joule, and we know that 1 calorie is equal to 4.2 joule. Okay, if I discuss the heat or describe the heat in terms of molecular state of a body or substance. For example, let us consider a body. You know that solid object or body contains millions of molecules, and each molecules are each of the molecules vibrates all the time, always vibrates, and this vibration is can be considered as a periodic motion, like the motion of a spring. Okay, the molecules vibration, the characteristics of the vibration of these molecules is almost same of the vibration of a spring or periodic motion, simple periodic motion. And this vibration has kinetic energy. The kinetic energy of kinetic energy of molecules can be expressed in terms of heat. As we can't see the vibration of these molecules with the naked eyes, so we feel when it touch this body, we feel hot or cold. If the temperature of my hand is higher than this body, then I feel cold, or if the temperature of my hand is lower than this body, I feel hot. And the most important thing regarding heat is that how much heat transfer when the two body comes into closer contact, thermal contact. Before discussing the temperature, I will normally I ask the students a questions. The question is, let us consider two object. First one is first A, and then second one is B. The heat energy of this body, let us consider 200 joule, and the heat energy of this body 3 300 joule. That means to increase the certain temperature of this body, we supplied 200 joule energy of this heat energy of this body to this body, and to increase the temperature of this body we supplied the 300 joule. But we have no other information except this. That means 200 joule and 300 joule. If the two body is connected, that means if the two body in thermal state, in thermal contact, then the question is, what is the direction of heat? Direction of heat. Most of the student answer give the answer that from B to A. Though the answer is not correct, because we can't say the direction of heat without knowing of most important information of this body, and the information is the temperature. Without knowing the temperature, we can't say the direction of heat. As we know that heat transfers from heat is transferred from higher temperature to from higher temperature body to lower temperature body. So we have to give another information except this information. The information is the temperature. Now let us consider the temperature of the body B is 30 degrees Celsius, and the temperature of body A is 40 degrees Celsius. Now we can say that temperature, as the temperature A, body A is higher than the body B, so heat will transfer from A to B. In this situation, a critical question you may ask to me, and the question is, why the temperature is 40 degrees Celsius? Because the body gains 200 joule heat energy, the body A, whereas the body B gains 300 joule energy. So why the temperature of body A is higher than the temperature body B? To explain this, this the reason is that the specific heat of specific heat of a material. This is possible because only possible because if the material of this body is if the material of this body is different. Let us consider A is copper, made of copper, and B material, B body is made of iron. As the material of this body is different, so although the supplied energy, heat energy is different, the temperature although the supplied energy to body A is lower than the body B, the temperature may higher because the material of this body is copper and the material of this body B is iron. And this due to this property, specific heat of a material, let us give an let us give definition of specific heat of a material. Already I have explained that due to that property of a material, by gaining the same energy, the temperature is different. The property of the material is called a specific heat. By supplying equal amount of energy of a two body, the temperature may be different. Okay, I will explain later. Just writing the definition. Okay, the heat energy needs to increase the temperature of 1 kg body by 1 Kelvin is called specific heat. That means the heat energy is required to increase the temperature 1 Kelvin of a body of mass 1 kg. Let us consider a body. Mass of this body is mkg, and we will increase the temperature by del theta Kelvin. Del theta means change of temperature. It may be increment or decrement, change of temperature. And to change this temperature of this body, heat, the amount of heat supplied to this body is Q joule. So in reality, in real experiment, normally we increase the temperature higher than 1 Kelvin, maybe 5 Kelvin, 10 Kelvin to 100 Kelvin, something like that. And the mass of this body is not necessarily to be 1 kg. It may be 5 kg, 10 kg. That's why we denote the mass of this body by m, and the change of temperature by del theta, and the supplied energy is q. So we can write in this way: the supplied heat q, joule heat uh, for mkg mass to change temperature by del theta Kelvin. Let me write this way: del theta Kelvin delta to Kelvin by temperature delta to Kelvin. Uh, Supplied heat is Q joule. For 1 kg mass, to change the temperature by 1 Kelvin, supplied heat should be Q divided by M divided by del theta, right? Joule. This should be capital, not a smaller. So, according to the definition of specific heat, the amount of heat needed to change the temperature del theta of a body of mass 1 kg is specific heat. And we denote the specific heat by S, capital S, specific heat. Okay. So we can write, now we can write S equals to Q divided by M into del theta. This is the equation of a specific heat, and by rearranging this equation, we can write Q equals to ms del theta. So this formula is used to calculate the amount of heat transfer from a body to the another body. Normally, we don't have to we don't need to determine the internal heat energy of a body. For example, the internal heat energy, normally we don't need to calculate or measure the heat energy. What we will do when this body is in thermal contact with another body, the heat will transfer. The body A may be release heat or may gain heat from body B. Whatever it is, the transfer energy from A to B or B to A, we can calculate the heat energy by this equation. Okay. If it is Q, we can calculate the amount of heat by using this formula. So we need to know about the mass, specific heat, and the change of temperature. It may be decreasing or increasing. So let us uh, already I have shown in the outline that I will discuss some mathematical problems. And the first one is that the mass of a calorimeter is 200 gram. Let me cut these questions and paste it here. Yes, now it's easier to understand the problems. The mass of a calorimeter is 200 gram and a specific heat of material is 400 joule per kg per Kelvin. This is the unit of specific heat. I will discuss how this unit is determined. The question is that calculate amount of heat needs to increase the temperature to 70 degrees Celsius from 20 degrees Celsius. Here, the calorimeter is a instrument. By using the instrument, we can determine the temperature of a body. Sorry, that amount of heat transfer from a different body. We can calculate. Okay. The information given here is that the mass of a calorimeter, that means M equals to 200 gram. We need to convert gram to kilogram. 200 divided by 1000, 1000, that means 0.2 kg. Okay, kg. and the specific heat is 400 joule per kg per Kelvin, and the temperature difference, that means final temperature minus to initial temperature, that means theta 2 minus theta 1. We can write as well theta f minus theta I. Theta 2 here is 70 degrees Celsius, that means final temperature, and the initial temperature was 20 degrees Celsius. So temperature change is 50 degrees Celsius. But it is to be noted that during this type of solving mathematical problem, we have to use the unit of temperature as Kelvin, not degree Celsius. Normally, we know that by adding 273 with temperature Celsius, we can calculate the Kelvin. But here, keep in mind that temperature is temperature difference. So temperature difference in two scale, that means Celsius and Kelvin scale, is same. So that means we can write 50 degrees Celsius equals to 50 Kelvin. The question is, uh, what is the heat energy required? So we know that Q equals to ms del theta. Very simple problem, and by putting the values of the parameters of the m, that means 0.2, specific heat 400, and 50 Kelvin. We don't need to write the unit. So that is 0.2 400, I mean only 1600 maybe. Let me calculate the value. I'm using the calculator. Okay, let me use this calculator first. Calculator. 0.2 times 400 times 50, weight is 0.2 400 in times 4000. Okay, 4000 joule. Okay, now the question 2. Before going to this going to question 2, I will show the unit of specific heat. We know that the unit of specific heat, already I have shown that joule per kg per Kelvin. So we know that specific heat is equal to Q divided by m del theta. Right? So by writing the unit of these parameters, we will have the unit of specific heat. That means the unit equals to Q, that means joule, unit of heat, mass kg, and del theta is Kelvin, or joule per kg per Kelvin. So now we can describe the question like this question. What do you mean the specific heat of a body? What do you mean the specific heat of a body is 400 joule per kg per Kelvin, specific heat of a body. Okay. So here should be per kg per Kelvin. We can write that by 400 joule per kg per Kelvin specific heat of a material. We mean that the heat energy required required to increase the temperature of that body of mass 1 kg by 1 Kelvin is 400. That's very simple answer. Now let us see a simple questions. For example, the body, two body, one is copper and another is iron. So we will increase the temperature of this body, of both of this body, by 1 Kelvin, by 1 Kelvin. Okay, the mass of copper is 1 kg, the mass of this iron is 1 kg. So question is that what is the amount of energy and amount of heat energy required to increase the temperature by 1 Kelvin. Okay. Very simple question, and the condition is also very simple. Both of this body mass is 1 kg and the temperature change is 1 Kelvin. But the important parameter is that the material of this body is different. One is copper, another is iron. So the amount of heat supplied to this body must different because the material is different. And to answer this question, we have to know the specific heat as as it is directly related to the material, and we have to know the specific heat of copper and a specific heat of iron. Without knowing this information, we can't answer this question. So already I have told that the specific heat of copper, that means S copper, is 400, right? 400 joule per kg per Kelvin, and the specific heat of iron is 460. I will give a chart, a list of specific heat of different materials. Now, as the specific heat of iron is 460, which is higher than this copper, that means we have to give a higher energy to the material Fe, iron, uh, because the specific heat is higher. So we can write that the supplied energy for copper is 400 joule and supplied energy to iron, supplied heat energy to iron is 460. The key information is that the message of this question is that although we are supplying the different energy to different body, the increase or change the temperature is same. Okay, that means we can write that although the supplied heat energy is different, the temperature change may be same, maybe same. Condition is that material should be should be different. Okay? Very important informations. And also we can write in this way, although the supplied heat energy is same, temperature change may be different. Condition is that material should be different. Already I have explained the first one by giving an example. This one. I will describe this the later one by another example. Very simple example. Let us consider two material. One is one is copper and another is I will give the material name. Just let me give the chart first. Specific energy of different material. Okay, just a minute. Yes, silver is 230. So I can write here silver because silver is 230. Okay, the condition is that we are supplying the same energy to this body. Let us 1000 joule to this body, and also 1000 joule to this body. And the mass of both of this body is 1 kg. And the question is that what is the temperature change of copper and what is the temperature change of silver? To answer these questions, we have to know the specific heat. And already I told that specific heat of uh, copper is 400 joule per kg per Kelvin and the specific heat of silver is 230 joule per kg per Kelvin. Okay, so by utilizing this information, we can calculate the temperature change for copper and the temperature change for silver. Let us temperature change for copper first. We know that Q equals to ms del theta. So by rearranging this equation, we can have del theta equals to Q by ms, right? Q here is 1000, mass is 1 kg, but only the specific heat energy is different. So here is 400. So we can write 1000 by divided by 400. That means 2.5 Kelvin. Temperature change del theta is 2.5 Kelvin, as the difference of temperature in 2 scale Celsius and Kelvin scale is same, so we can write 2.5 degrees Celsius as well, the temperature change for copper. Similarly, we can write for the silver, temperature change del theta 1000 divided by 1 by 230. So here 1000 divided by 230 is equals to 4.34, right? So 4.34 Kelvin first, and then we can write in terms of degrees Celsius, 4.34 degrees Celsius. The temperature change is different, although the supplied energy is same and the mass is same, but due to this different of material, the temperature is change is not the same. That's why I have written that although the supplied energy is same, the temperature change may be different if the material is different. Okay, so this is for specific heat energy, and now the capacity of heat, the last items to describe. Okay, capacity of heat capacity. Normally I explain with example. I prefer by giving an example. So let us consider two objects of same material. Now I'm not concerning the material, I'm concerning about the object. For example, let us consider a glass which is made of copper, and the jug which is made of also copper. Okay? But the uh, mass is different, may be different, or should be different, because the body or object is different, although the material is same. So by heat capacity, we mean that the heat energy required, heat energy required to change the temperature by 1 Kelvin is called capacity of heat. That means heat capacity. The capacity of heat, it doesn't relate it to material directly. Rather, it depends on the material. It depends on the object, type of object. Maybe glass, maybe jug, maybe bucket, something another object maybe. Okay. So here we can relate, but we can make a relationship between the heat capacity. We write the heat capacity by C, using the C. C means capacity, heat capacity. So very simple way we can write that C is a difference on the Q, and also the temperature difference del theta. So that means we can write Q equals to C del theta. Is the equation number one. Already we know that Q equals to ms del theta. Ms del theta. That's number two. So by comparing equation 1 and 2, we can write that ms del theta, sorry, c del theta, c into del theta equals to ms del theta. So by cancelling out del theta from both sides, we can write the c equals to ms. This is the relationship between heat capacity and the specific heat. Only multiplying by m to with a specific heat we can have the capacity. Okay, so last example I'm going to show, already I have mentioned here. Okay, the example is that so the question is that 1800 joule heat energy needs to raise the temperature of a 100 gram container pot made of aluminum by 20 degrees Celsius. Calculate the specific heat of that material. It's very simple. We know that Q equals to ms del theta. So we can rearrange that as Q divided by m del theta. So here m is 0.1 kg and del theta equals to 220 degrees Celsius or 20 Kelvin, and supplied heat energy is 1800 joule. The question is that what is the specific heat? So by putting the information here, Q 1800 divided by 0.1 to 20, so we can, this one is 1800, so we can calculate this by 1800 divided by 0.1 times 20. Okay, so 900 joule per kg per Kelvin. This is the end of this lecture. Before finishing this lecture, I'm going to show the homework to practice yourself. The number one, we need to increase the temperature of water of 750 gram by 20 degrees Celsius. Calculate the amount of heat needs to raise the temperature. Specific heat of water is 4200 joule per kg per Kelvin. Everything. Okay, the how much the mass of water if 200 joule heat energy needs to raise the temperature by 200 by 20 Kelvin. The question 3 is that a 20-gram iron ball is heated on a copper container of mass 500 gram and 5000 heat energy supplied to that container until the temperature reaches to 50 degrees Celsius. Calculate the initial temperature of the iron ball before heating. The hints of this question is that first we have to determine the temperature change by using the formula Q equals to ms del theta. Here, the key information is that the supplied heat, uh, 5000 joule, will be divided into two parts. One part is for temperature change for iron, and then the second part is used for changing the temperature of copper container. So that's why we can write in this way Q1 plus Q2 equals to Q. Here Q is the 5000 joule. Q1 heat needs for ball. It needs for container Q2. As the temperature change is same because both of this material is in closer contact, thermal contact. So temperature of both of this body is same. That means M1 S1 del theta plus M2 S2 del theta. So by writing this formula and using this formula we can calculate the del theta, and then we can calculate the initial temperature. As you know, the final temperature is 50 degrees Celsius. So the last question is that calculate the amount of heat energy needs to raise the temperature of a 50-gram body by 20 degrees Celsius. Also, what is the specific heat of that body? Only the information is here. The heat capacity of that body is 300 joule per kg, joule per Kelvin. So first, we can calculate the specific heat first by using the formula. We know that C equals to ms. So we can calculate the specific heat by this formula, and then we can calculate the heat energy Q equals to ms delta. Okay. So this is the finishing of this lecture. I will invite to see what's the next lecture, lecture 2. I will give the notification when the lecture will ready. Okay, thank you.